Hello everyone, I am Dr. Kiranmayi, Area Chair Assistant Professor, Digital Transformation and Operations, Department of Management Studies, School of Business, Aditya University. In this present lecture, I am going to discuss how to use binomial probabilities and Poisson probabilities, how to calculate in a given situation or for a given case in real time for a decision making. So, the formula for binomial probability is given by x is equal to r, NCR p power r q power n minus r, where r runs from 0, 1, 2 and up to n. So, this is the formula to calculate binomial probability. And here we are given that suppose it is known that 4% of all emails are spam. So I have in the previous lecture we have learnt that in binomial distribution or to calculate binomial probability, the outcomes should be two mutually exclusive outcomes. Here the mail may be spam mail or non-spam mail. So I am considering small p as that a mail is a spam mail, and the mail is the chance for a mail to be a spam mail is 4%, that is we have given in the problem 4%, that is 0.04. And so p, let us consider p as the probability of success, q as probability of failure. In this example, p is that a mail is a spam mail, q I am considering that a mail is a non-spam mail. Then the value of q is, remember the total probability, since the result, the possible outcomes of the experiment is going to be only two mutually exclusive events, that is the total probability should be 1. So, one condition for probability, the probability lies between 0 and 1. So, the total probability of the two events must be 1. Therefore, q is going to be 1 minus 0.04, that is 0.96. So, p is, so therefore 4% chances are there for that a mail to be a spam mail. It means that there are 96% chances that the mail is a non-spam mail. It is the information which we are given. If an account receives 20 mails in a given day, so this 20 mails we can consider it as n value, fixed number of experiments as we can consider 20. If we consider 20 mails, that is it is 20 independent experiments as we can consider it as. Okay, so n is 20. We can use, we are asked to find out the probability of certain number of those mails. Say for example, so one may be interested that what is the probability that the no mail is a spam mail, all are legitimate mails. So that is p of x is equal to 0 we want to find. For example, somebody may be interested, what is the probability out of 20, one mail is going to be a spam mail. And another may be interested in what is the probability out of 20, 2 mails are going to be spam mails. So, based upon the information, we can find out answers for all these probabilities. So, now we have to find out p of x is equal to 0. P of x is equal to 0 means, so out of 20, what is the probability that no mail is a spam mail? All are the legitimate mails. So, the formula for binomial probability is given as NC0 p power r q power n minus r. In this problem, p is 4%, that is q is going to be 96%, that is 0.04 or 0.96, and n is, in this problem we are given 20 mails, so n is 20. Therefore, 20 C is 0, 0.04 whole power r value, it is 0 here, and q is 0.96 whole power n minus r, that is 20 minus 0, 20. And 20 C0 value, it is going to be 1, and it is, if any value power is, if x power, we know that x power naught value is 1, a power naught, 1000 power 0, its value is 1. Therefore, its value is 1 and 0.96 whole power 20. So, 0.96 whole power 20 and this value is going to be 0.4420, that is 44% chances. So, what is the probability that there will be no spam mail out of 20? Therefore, there are 44% chances are there out of 20, no mail is going to be a spam mail. Okay, so this is how we can make use of this binomial probability for making decisions. And somebody may be interested in knowing that out of 20, what is the probability that one mail going to be a spam mail. So, here also 20 C1 P power R Q power 19. If we compute, we are going to get this answer, that is 0.368. So, that is 36% or approximately it is 37%. Therefore, 37% chances are there out of 20, one mail to be a spam mail. So, this is another way how we can calculate the binomial probabilities. So, next coming to Poisson probability. So, in here we have this is the formula to calculate Poisson probability, that is probability of particular number of events, occurrence of particular number of events. Okay. So, we are given that there is a call center which is receiving 10 calls per hour. It is receiving 10 calls per hour, average number of calls in an hour. We can say lambda value we are given 10. We can use to find the probability that a call center receives 0, 1, 2. So, what is the probability that a call center does not receive any call in 1 hour? Say for example, there is a call center. What is somebody may be interested in that, what is the probability that call center will not receive any call in 1 hour? That is, we are asked to find out P of x is equal to 0. Why should we use Poisson probability here? We are not given fixed number of trials or fixed number of events, where here the time is also continuous. The occurrence of the event runs in continuous, is a continuous area, a continuous time, and also here the event that is receiving calls are rare events. Therefore, we have to use here Poisson probability. So, lambda is 10 and we are asked to find out P. For example, one may be interested in knowing what is the probability that in 1 hour the call center will not receive any call, that is P of x is equal to 0, and the formula is lambda. What is lambda here? It is 10. So, 10 power k value is 0. So, x is equal to k here. So, 10 power 0 e power minus 10 whole divided by 0 factorial. So, if anything we have in power 0 for any number, it is going to be 1, its value is going to be 1, 0 factorial is 1. So, ultimately it is e power minus 10 whose value is 0.005. Okay. So, this is the probability of that the call center will not receive any call in 1 hour. Likewise, we can calculate for P of x is equal to 3. So, lambda value is 10, that is 10 power 3 into e power minus 10 whole divided by 3 factorial, and this is going to be 0.075. So, that is a firm may have 0.007 chances that the call center will receive 3 calls in 1 hour. So that is into 20 we can identify what is the probability that the firm is going to, the call center is going to obtain 3 calls. Okay. So this is how we can make use of Poisson probability to in real time cases. So in this lecture we have understood how to use binomial probability, when to use binomial and Poisson probabilities, how to calculate these probabilities for decision making, how to interpret those values we have understood from this present lecture. Thank you.